Now let us examine another market structure called oligopoly. An oligopoly refers to a market structure in which we have few firms or few competitors, and in fact they are so few that you can count them on your fingers. To give you an example, look at how many companies produce large commercial aircrafts. In terms of the market share, there are only two big companies. One is Boeing, which is in the US, and the second one you have is Airbus, which is a collaboration between France and the UK. Another example could be, look at the beverage industry. You have Pepsi and Coke. Yet another example could be, look at how many auto manufacturers we have in the world, and you can count them on your finger. Now, a key characteristic of oligopoly, or a situation like oligopoly where we have few competitors, is it entails interdependence in decision making. What one company does with its product has an impact on the other companies under oligopoly, and what the second company does with its product has an impact on the first company. To give you an example, let's look at something outside the business world. Look at a classroom setting. You can divide the classroom into two, one being the teacher and the second one being the students, all students within a class. Now, how I behave with my students in part depends on how my students behave with me. Similarly, how do my students behave with me in part depends on how I behave with them, and thus there is interdependence in decision making. Now, there is a new branch or a new technique of analysis called game theory, which has developed over time, which explicitly models interdependence in decision making. And game theory is a very interesting and a complicated area, and the first model that we come across which modeled oligopoly or interdependence in decision making is due to a French mathematician called Cournot, and I think this was written around 1860s. So let us examine the first model of oligopoly. Now let us look at the assumptions made by Kunos. He assumed that there are only two firms in a particular industry, or what he looked at is a market structure called duopoly. Now there are two firms and each of the two firms maximize total profits. That's their objective, to maximize total profits for themselves. Whenever we look at interdependence in decision making, how you behave with your rival in a way depends on how you expect your rival to behave. And in this case, what Kunos assumed is the following, that each firm, regardless of what output it produces, the other firm will hold its output as constant at the existing level. Thus, in other words, each firm takes the output of the other firm as given, and then it tries to do the best it can or chooses its output that maximizes total profit. And so this is an assumption about expectation, and they could be called naive or very basic. You assume that the behavior of your rival will be the same, or it will produce the same level of output, and based on that you can go ahead and find the output level which will maximize total profits. And the last assumption he made is the firms do not communicate with one another, or it is an example of a non-cooperative situation or a non-cooperative game. And what is a non-cooperative situation? In which firms do not communicate with one another. So the key assumption under Kunos is that each firm takes the output of its rival as given and tries to figure out what will be the best level of output for itself. So, or in other words, makes a conjecture or different conjectures about the behavior of its rival. For example, firm 1 believes that firm 2 will produce absolutely nothing. One conjecture by firm 1. In such a case, the entire market demand for this product belongs to firm 1. Why? Because firm 2 will produce nothing. Now the market demand curve or the average revenue curve is downward sloping. Based on this, we know the MR curve will lie below the average revenue curve. So this green line represents the marginal revenue curve. And let us assume for simplicity that the marginal cost curve is horizontal. And based on a condition for equilibrium, that is MR equals MC and MC intersects MR from below. So this must be the equilibrium point for firm 1 when it believes firm 2 will produce nothing, and accordingly it will determine what will be its optimal level of output, and that will be 150 units. So when firm 1 believes that firm 2 will produce nothing, in such a case firm 1 will produce 150 units of output. Now let us look at another conjecture made by firm 1. Firm 1 believes that firm 2 will produce 100 units of output. Now we have the market demand curve, and now what we are trying to figure out is the demand curve for firm 1. Now out of the market demand, firm 2 produces 100 units of output. So what we can do is we can remove 100 units of output from the market demand curve, and we derive a residual demand curve for firm 1 when firm 2 will produce 100 units of output. Now based on this residual demand curve for firm 1, we can derive a residual MR curve for firm 1. We still have the same marginal cost curve, and again we know that this point will be the equilibrium point, and if firm 1 believes that firm 2 will produce 100 units of output, the profit maximizing level of output for firm 1 will be 100 units. Now let us look at yet another conjecture made by firm 1, and now firm 1 believes that firm 2 will produce 200 units of output. So like we did on the previous slide, from the market demand curve we knock off 200 units of output and we derive a residual demand curve or the average revenue curve for firm 1. Based on this AR curve, we can derive the residual marginal revenue curve for firm 1 when it assumes firm 2 will produce 200 units of output. Once again we have this equilibrium point, and based on this, when firm 1 believes firm 2 will produce 200 units of output, the profit maximizing level of output for firm 1 will be 50 units. Now let us summarize all that we know based on the diagram, and we'll call this summary reaction table, and this is table for firm 1. Now look at the different levels of output, profit maximizing level of output, when firm 1 makes conjecture about how much output will be produced by firm 2. For example, when firm 1 believes firm 2 will produce nothing, we discovered that the profit maximizing level of output for firm 1 will be 150. When it assumed that firm 2 will produce 100 units of output, the profit maximizing level of output for firm 1 is 100 units. And when firm 1 believed that firm 2 will produce 200 units of output, the best output for firm 1 then is 50 units. So this is a summary reaction table for firm. Though we have not drawn diagrams, but let us assume that the reaction table of firm 2 looks pretty much like what we have for firm 1. So in the first column we have firm 2's profit maximizing level of output, and here are different conjectures made by firm 2 about firm 1's output. For example, when firm 2 believes that firm 1 will produce nothing, in such a case the profit maximizing level of output for firm 2 will be 150. When it assumes firm 1 will produce 100 units of output, the profit maximizing level of output for firm 2 will be 100, and in this way we have this reaction table for firm 2 as well. Now, based on the reaction tables we had for firm 1 and firm 2, we can draw diagrams and we can call them firm 1's reaction curve and firm 2's reaction curve. Now, on this diagram we have output of firm 1 on the vertical axis and output of firm 2 on the horizontal axis, and this is based on that information we have is firm 1's reaction curve. Now look at the following. When firm 1 believes firm 2 will produce nothing, in such a case firm 1 will produce 150 units of output. When firm 1 believes that firm 2 will produce 100 units of output, in such a case the best output for firm 1 is 100 units. And then the last possibility, when firm 1 believes firm 2 will produce 200 units of output, in such a case firm 1 will produce 50 units of output. In a similar way we can draw firm 2's reaction curve, and wherever these two reaction curves intersect, what we have is an equilibrium point, and this equilibrium point is called Kunos Equilibrium, and this will be the outcome under Kunos Equilibrium. Each firm will produce 100 units of output. Here are the definitions we have used, and look at reaction curve for firm 1. What is it? It simply shows us how firm 1 will react as a function of how much it thinks firm 2 will produce and sell. And in a way, these reactions are based on different conjectures, and based on different conjectures firm 1 reacts and tries to figure out what is the optimal level of output. So this is what reaction curve for firm shows. In a similar way we define reaction curve for firm 2, which simply shows how firm 2 will react as a function of how much it thinks firm 1 will produce and sell, and it's essentially firm 2's reaction to different conjectures that firm 2 makes about firm 1. And then we looked at Kunos Equilibrium. And what is Kunos Equilibrium? Where two reaction curves intersect, or where each firm's expectation about the other firm's behavior is correct, and that's when we have Kunos Equilibrium. A quick recap of what we have accomplished in this lecture video. We are looking at a market structure called oligopoly, which is essentially competition amongst few. There are so few competitors that you can count them on your fingers. And when you look at a market structure like oligopoly, this entails interdependence in decision making, and to model interdependence in decision making has been hard for economists / philosophers, and the first attempt to model this was done around 1860s by a French mathematician called Kunos, and what he looked at is a situation in which we have two firms, or a situation of duopoly where each firm takes the output of its rival as given and tries to do the best it can under the circumstances, Kunos model. So this completes our discussion and this lecture video. Thank you for your time.